Acclimatisation. Many people, whether they are builders, architects or owners, have heard of acclimatisation, but it is obvious that there are misconceptions that have led to poor practices that are either unnecessary or incorrect. It's important to understand when it is appropriate to consider acclimatisation and how it should be done. Let's look at the specifics of acclimatisation: why it's done, what needs to be considered, and how it's done. Acclimatisation is also used for other products, including engineered laminate and bamboo, and we'll briefly discuss its meaning in this context. We need to understand the influence of relative humidity on solid timber flooring, which is generally manufactured at an average moisture content of 10% to 11%, which is suited to an average internal RH of 55% to 60%. In Melbourne, with winter heating and dry summers, internal RH may average 50% to 55%. Solid timber floors are more prone to shrinking a little after installation. In Brisbane, with warm and moderately humid summers, the internal RH may average 55% to 65%, and floors may swell a little during more humid times. So, you can see that, after manufacture, in some in-service climates, flooring can be expected to shrink. In some, there will be little movement, and in other locations, the flooring can be expected to swell. This is shown in the diagram on the right. High humidity causes an increase in moisture content and a corresponding increase in board width. Conversely, low humidity causes board moisture contents to reduce and decrease the board width. We need to understand EMC, or equilibrium moisture content, which is the moisture content that timber approaches under set conditions of relative humidity and temperature. An example, as seen in the last slide, is if the relative humidity was 60% and the temperature at 20 degrees Celsius, then the EMC is 11%. A floorboard that's, say, 9% moisture content held in these EMC conditions would with time adjust its moisture content to be near 11%, or a floorboard at 14% moisture content would with time adjust its moisture content to be near 11%. The lower moisture content board increasing in width and the higher moisture content board reducing in width. This table shows EMC values for different relative humidities and temperatures. In general, it can be said that to minimise movement, shrinkage or swelling after installation, it is necessary to install flooring as close as possible to the average internal EMC of the dwelling. So, if flooring was supplied at, say, an average of 10% moisture content and the in-service average EMC was 13%, then the flooring is going to swell. Acclimatisation in this instance is about letting it swell prior to installation so that when it is installed, the average moisture content of the flooring is closer to 13%. By doing this, expansion problems are avoided. How much does the board width change with changing moisture content? If a board is not restrained by fixing, then an 80mm wide piece of flooring will move, shrink or swell, about 0.25mm for each 1% change in moisture content. The process is illustrated in these two graphs. On the left-hand axis, we have moisture content, and the horizontal axis is time. The first diagram illustrates raising the average moisture content through acclimatisation in a humid in-service environment from an average moisture content of 10% up to 13%. The second diagram shows a lowering of the average moisture content in a dry in-service environment from an average of 10% to 8.5%. Acclimatisation is the process of adjusting the average moisture content of the flooring to be closer to its expected in-service average moisture content prior to laying, to reduce post-installation shrinkage in dry climates and post-installation expansion in humid climates. This diagram can be found in many publications and manufacturers' information and provides guidance on when to and when not to consider acclimatisation. Most floors do not need to be acclimatised, as indicated by the normal in-service environment line in the table. That is, the flooring has already been manufactured to suit the dwelling environment in which it is going to be laid. Note that if the conditions are not suitable, for example acclimatising at the dry time of the year in a humid locality, then acclimatisation can result in performance problems. When considering acclimatising solid timber flooring, there are 4 aspects that need to be assessed. 1. Board width. 2. How well the flooring has been dried. 3. The flooring species. And 4. Locality and dwelling influences on internal climate. The top image shows timber stacked to allow airflow through each layer of timber flooring. Hence, each board is exposed to the lower humidity environment in the art gallery. The purpose of the acclimatisation is to lower the supplied average moisture content. To acclimatise solid timber, it must be strip stacked as shown in the photo. When considering acclimatisation and board width, remember that a 3% change in moisture content of an 80mm board will cause the width to change by 0.75mm. A 3% change in moisture content of a 180mm board will cause the width to change by 1.7mm. Therefore, there can be greater variation in board widths when acclimatising wide boards than narrow boards. Flooring is generally manufactured with board moisture contents between 9% and 14%, in line with the Australian standard. So, if some boards were to reduce by 3% in moisture content, then they could be 1.7mm narrower after acclimatisation. It can be more difficult to get a consistent result with wider boards. This is not only due to the effects shown in the previous slide, but also due to the natural moisture uptake and loss from timber flooring. Moisture enters or leaves board ends more quickly and can swell or shrink board ends. Hence, there can be greater unevenness in board width when acclimatising wider boards. How well the flooring has been dried is also important. As mentioned, hardwood flooring is generally dried to be within 9% to 14%. The top graph illustrates flooring complying to this, with most boards reading 9% to 11%. If the average EMC is 10%, then some shrinkage would occur in a few boards, and the variation in cover width relatively small at 82.7mm to 83.3mm. However, if the drying distribution is wide as shown in the second graph, and the flooring not produced to meet the Australian standard, then the many higher moisture content boards will shrink and create a significant variation in cover widths. Therefore, if the flooring is not dried properly, acclimatisation causes greater variation in width. When considering species effects, Jarrah is more responsive than spotted gum to absorbing or releasing moisture to the atmosphere, so it will acclimatise faster. An understanding of the species to be installed is beneficial, and in general, high-density hardwoods acclimatise more slowly than medium-density hardwoods. Blackbutt, however, is an exception and will acclimatise quite quickly. The photo shows a testing chamber where the EMC can be set and where trials were undertaken to assess the response of common flooring species. The chamber was set to high humidity conditions for 3 weeks, followed by low humidity for 3 weeks. The graphs show the difference in response rates between Jarrah and spotted gum, and where Jarrah is more responsive than spotted gum. In 3 weeks, Jarrah's moisture content changed by about 4% compared to spotted gum at about 2.5%. Jarrah has a density of 780 kilograms per cubic metre compared to 1100 for spotted gum. Heating and cooling systems can have a significant effect on internal climates. However, as we adjust the internal climate in our homes to where we feel comfortable, with moderate use of air conditioning and heating systems, this creates conditions in which timber floors perform well. Often people's preferred internal climate is in an EMC of 9% to 12%. In Melbourne, for example, evaporative coolers add humidity to the air in summer when the external air is dry, while in winter, heating lowers internal humidity when it's high externally. In subtropical areas, there is little winter heating, but humidity is not high, and in summer, refrigerative air conditioning moderates high external humidities. However, excessive use of heating and cooling systems can have a detrimental effect on floors in all areas. When considering the process of acclimatising solid strip timber flooring, you need to 1. Know the current conditions. 2. Know the expected in-service conditions. 3. Consider the board width. And 4. Know the board moisture contents. When assessing current conditions, a quick look at weather data can show whether you are in a dry or more humid time of the year. This is illustrated on the graph. To allow for local conditions, simply view the site. With the house in the photo, the dwelling is often shaded. See how lush the vegetation is? Estimate the moisture content of existing timbers. Also consider internal heating and cooling. An inexpensive humidity meter can be very useful. In the dwelling shown, the internal EMC is likely to be higher, so the aim of acclimatisation would to be increase the average moisture content and thereby increase board cover width prior to laying. This process is likely to be more effective in warmer and more humid summer months. An example is this dwelling in tropical North Queensland, a humid location. Consider a floor supplied at 9.5% average moisture content, and the internal conditions, the EMC, is expected to average 14%. An 80mm wide board will expand about 0.25mm for each 1% change in moisture content. So, a 3% increase in moisture content should make the boards about 80.7mm wide. The graph shows what acclimatisation aims to achieve. One process that has worked quite well is to determine the average estimated moisture content prior to acclimatisation. In this example, it's 10%. Strip stack the boards in layers to acclimatise and place 10 shorter boards together and measure them. In the example, it measures 801mm. The aim is for the strip-stacked flooring and these 10 boards to absorb the humid air, the moisture content to increase, and in doing so, the cover widths to increase. 2 weeks later, more moisture content readings are taken, and again, the measurement over the 10 boards. The result is now 806mm and an average estimated moisture content of 11.8%. So, what is consistent is that we have had an increase in average moisture content of 1.8%, and an increase in average board width of 0.5mm. The acclimatisation worked. We will still need to add the usual expansion allowance into the floor, but on laying, our average moisture content is only 1.2% away from expected average EMC, whereas before acclimatisation, it was 4%. With other flooring products, such as engineered timber, laminate and bamboo, the word acclimatise often has a different meaning. Some manufacturers say no acclimatisation is necessary. Others say to use the processes used with solid timber flooring, while others state that storing for 2 to 10 days in the installation environment is necessary. Guideline intention is to bring the temperature of the new flooring close to that of the indoor environment, boards therefore not being subjected to temperature shock and distortion on opening. Acclimatisation is important. It describes a process, particularly with solid timber flooring, that can deliver well-performing floors in difficult locations, where the humidity may be high or conversely low. Important factors to consider are: 1. Before undergoing acclimatisation, it is important to have a sound understanding of the influence of relative humidity and temperature on both moisture content and board width changes in timber flooring. 2. Not all floors need to be acclimatised, and acclimatisation under unsuitable conditions can be detrimental to floor appearance and performance. 3. 4 aspects to consider when acclimatising solid timber flooring are board width, how well the flooring has been dried, and its average moisture content, the flooring species and the influences of the locality, and the dwelling on the internal climate. And 4. With other products including engineered, bamboo and laminate, the meaning of acclimatisation or acclimation differs to solid timber and describes allowing flooring to become accustomed to the installation condition in its boxes prior to laying.